Alright, good morning. Today we got a little different setup for today's video because I'm at home and filming it from the house. So, what we're going to talk about today is sea breezes and land breezes. This is a phenomenon that happens naturally near any kind of ocean or large body of water like Lake Michigan, the other Great Lakes, okay? I hope by now I've given you enough evidence to show that land heats up differently than water. Okay? From the labs that we've completed, you know that land heats up quicker than water does, but yet water should retain the heat longer. So what we're going to have is this uneven heating that gets transferred to the air, which means during the daylight hours, land above or air above a body of land is going to heat up faster than air above a body of water because the temperature differences in the land to the water as it absorbs the radiation from the sun. Now you also know that hot air rises, and because hot air rises, that means that we have this area of cooler, I don't want to say cold, cooler high pressure air that rushes in to replace all that hot air that's rising over the land. So during the day we have sea breezes, which is a wind coming off the ocean because warm air above it rises. Pretty straightforward. Remember, the key thing here to remember is that because water heats up slower, it transfers that heat to the air slower, which means the air above the ocean is actually a little bit chillier than the air above the land, which causes this higher pressure air to rush in as the water above or air above the land rises. Now at night we have the reverse of this. We have what's called a land breeze, and it's a wind that is coming off the land going towards the ocean because the water stays warmer longer. So at night after the sun goes down, from the labs we saw that the land cools off quicker than the water does. And because the land cools off quicker, that means the air above the land gets cooler faster, guys. The air above the water stays warmer, just a little bit warmer, than the air above the land. And because this air is warmer, this is the air that's now rising. And this cooler air, it's a little bit higher pressure, a little bit higher density, comes rushing in to replace it. Land breezes happen at night. So I want you to consider this. I've drawn for you two pictures side by side. I've got two little mountaintops in a valley. I've got two mountaintops in a valley. This side's during the day, this side's during the night. In the mountains, we have a similar phenomenon that happens with valleys and mountains. I want you to think about the uneven heating that occurs with the sea breezes and land breezes, and think about how uneven heating might occur during the daytime with mountains and valleys, and then at nighttime, how that heat's retained with mountains and valleys. I want you to take a guess tonight and try to figure out where you think the high pressure is, where you think the low pressure will be, in which direction the winds will blow during the day. Will they blow from the mountaintops down into the valleys, or from the valleys up into the mountaintops? And then at night, will the wind blow from the mountaintops to the valleys, or from the valleys to the mountaintops? Take a gander, try it out, think about it a little bit. Remember, uneven heating is going to be the key. What part of the mountains are going to heat up first as the sun comes up? What parts are going to cool off faster? Give it a try. We're going to discuss that tomorrow and take any questions you got.